friends, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the gaseous fuels, its composition and characteristics as a part of green chemistry. So here are the topics. Before going to the actual topic, we have to discuss the definitions of what is a gaseous fuel, then types of gaseous fuels, like different types, manufactured fuels, or the gases that are manufactured, then natural gas already occurring in the nature from the earth crust that we have obtained during the refining, then petroleum gas, what is the petroleum gas and its forms during our applications. So gaseous fuels, daily we are using one of the best example is LPG gas that we are using for the cooking. So this is the best example that we are using domestically, LPG. That is one of the form of gaseous fuels. So these are much cleaner. So when we compare to our traditional cooking from the coal or wood, so this is clean because there is no smoke that is producing from this source. So much cleaner than liquid and solid fuels. So what are liquid fuels? Like petrol, biodiesel. So these are the examples of liquid fuels, and solid fuels are coal, wood. Wood is nothing but obtained from coal. So these are the examples of solid fuels. So that are used. So these gaseous fuels can be used directly using the burners and combustion chambers. So this is the best example and advantages. However, due to their low density, their energy density is also low. It means the energy released per unit volume of gas is low because it has low energy density. So low density, so therefore it produces low energy density. So it requires to be compressed. So the need for compressed storage in the pressure vessels with proper regulators. If you see our cylinder, general cylinder that we use for cooking is the compressed gas, because we are, that is why we are fitting with the regulators, so that we will be sending only desired flow through the regulator. So these gases have high calorific value. So these have very good calorific value that gives good energy for heating or cooking purpose. So the calorific value and the specific gravity of gaseous fuels determine the thermal output of a heating appliance. So any heating appliance, their output depends upon its calorific value and specific gravity. So this specific gravity, these two parameters like calorific value and specific gravity is very important. Specific gravity, these two parameters are of high importance before we apply for any applications. So gaseous fuels have lower energy content than liquid fuels such as petrol or diesel. So these have a low energy content. It means the energy produced will be lower. So gaseous fuels are potentially more deserved fuel as they produce low greenhouse gases. So energy produced is low, so the greenhouse gases produced are also low. For example, carbon dioxide or carbon monoxide produced from gaseous fuels are low. So upon burning, and hence air quality benefits are obtained compared to conventional and petrol diesel products. So when compared to coal or petrol, these carbon dioxide or carbon monoxide, for example, of greenhouse gases produced from gaseous fuels are lower content. So therefore it will maintain the air quality when compared to other types of fuels. So there are different types of gaseous fuels. So the one of them is manufactured fuel gases, that is manufactured by mankind, then naturally occurring gas, natural gas, and petroleum gas that we obtain from the refining. So from the refining also we get some gas that is nothing but the petrol gas. So for example, if we see manufactured gas, for example, if this is one of the manufactured gas or the biogas that is manufactured by humans, so that can be used for cooking purpose. And petroleum gas is liquefied petroleum gas, that is a converted one, so that is used in our domestic cooking purpose. So another one is a naturally occurring gas. So naturally occurring gas has different components like methane, ethane, propane, butane. So it has mixture of gases. Mixture of gases. So these natural gases contain mixture of gases. So this has methane, ethane, propane, butane, and condensates because it has some moisture also. Naturally occurring will have definitely moisture in it. So these are the different components that are present in the natural gas. So natural gas mostly, so the highest amount is the methane. So any compound or any fuel contain carbon component, carbon content. So this is the highest high percent. This is the high percent present in any form of the fuel. So liquefied petroleum gas or LPG has blends of several hydrocarbons like butane, propane, butene, propene. So they are alkanes and alkenes that are present in hydrocarbons that are present in LPG. And refinery gas is nothing but that we get product from refining technique that we have we have seen in the previous session. Product from refining. So that is nothing but the fractional distillation. So refinery gases got during the refining of petroleum having lighter hydrocarbons, carbon monoxide, and hydrogen. So these are the gaseous fossil fuels. So these are after obtaining the crude oil, the refining technique will help in obtaining different types of gases. So that one of them is a refinery gas. So that contains a mixture of hydrocarbons, lighter hydrocarbons, then carbon monoxide and hydrogen. So coal gas, producer gas, and synthetic gas are derived from coal. The name itself indicates that coal gas is obtained by burning coal, and solid fuels like other producer gas and synthetic gas are obtained after burning the solid fuels. So these are also examples of gases that are obtained. So biogas is derived from animal and plant waste. So this is also nowadays a lot of applications are seen for the biogas also, like the waste from the animals and plants are degraded properly anaerobically, and the gas produced is used for cooking and other domestic applications. So if you see in detail, the manufactured fuel gases. So these are produced through an artificial process. So we are manufacturing that gas. It means we are making that gas from an artificial process, usually called as gasification. So at a location known as gas works. So this is how we do. So examples are biogas and producer gas. So biogas is generally a mixture of methane and carbon dioxide, CH4 and CO2. So these are the mixture of methane and carbon dioxide together produces biogas. So if we see these, they are reacting together and forming biogas. Where are we really getting this methane or carbon dioxide? Just from the organic matter. So this we take slurries or the dung, cow dung from the cows, then energy crops, that wastage from the agricultural waste, and the food waste we mix together in a digester or a container so that there is no availability of air. So anaerobically, there is a digestion that is going on so that it produces carbon dioxide and the methane present in that particular sources or the waste material. So that is how there is a production of biogas, the mixture of methane and carbon dioxide that is produced from the waste material or the agricultural debris or waste. So after production, what happens? It is stored properly and used for electricity or heating purpose. Heating here is nothing but using for cooking and other purposes. So that can also be used for electricity generation and heating purpose. So this biogas is produced by anaerobic digestion with anaerobic bacteria or fermentation of biodegradable materials such as manure and sewage, municipal waste, green waste. Green waste is nothing but vegetables that we use, the waste from the vegetables, the plant material, whatever we are cutting down the plants during our gardening also can be used for production of this biogas, and crops waste. So these crops, after cutting the crop, there will be weeds left over or the stems left over. So that can also be used for the biogas production. So these organic materials are mixed in a container containing with anaerobic digestion. So biogas comprises primarily of methane and carbon dioxide and may have small amounts of hydrogen sulfide. Why this hydrogen sulfide is coming? Because there is a production of organic acids also from the plant and animal matters. So these organic acids will convert into sulfides. That sulfides are coming from the different components that are present. For example, this organic matter will contain carbohydrates, proteins, fats, oils, etc. So that will be breaking down into sugars, amino acids and fatty acids. This further with the digestion, during digestion further will convert into methane carbon dioxide and hydrogen sulfide. So this is the reaction that will go on and continuous. So the debris or the leftover or the residue will go into the effluents and the biogas can be utilized. Biogas can be utilized for our purpose. So the gases methane, hydrogen and carbon monoxide can be combusted or oxidized with oxygen. What happens when we oxidize carbon monoxide? It forms carbon dioxide, so that will increase again the content of biogas. So this energy release allows biogas to be used for as a fuel. So this is how the production of biogas takes place and can be used for different applications. So it is used as a fuel and many heating purposes such as cooking, and it can also be used for the gas engine to convert the energy of gas into electricity and heat. So there is a conversion from gaseous state to electricity and heat so that we can use it for different purpose. So this is a renewable energy. Why? Because the source renewable energy, because source is abundant. Source is abundant. Source from which we are producing biogas is abundant, because source is nothing but waste that we are producing in our daily life. So that can be used for heating, electricity and many other operations that can use a reciprocating internal combustion engine. So there should be some modifications in the engines or the electricity producing devices so that the biogas can be used properly. Even for the cooking, if we are using biogas, the burner size and dimensions will vary. So that is how we slightly modify our daily appliances and also industrial appliances or instruments so that we can use it for different applications. Next manufactured fuel is the producer gas. So a combustible mixture. What is a producer gas? That we are producing a combustible mixture of nitrogen, carbon monoxide and hydrogen. Nitrogen plus carbon monoxide plus hydrogen. This combination together will is called as producer gas. So it is generated by passing air with steam over burning coke or coal in a furnace and used as a fuel. So this, upon burning the coke or coal, will produce this mixture of gases and that can be used as a fuel. That is nothing but the producer gas. So producer gas is a mixture of carbon monoxide, nitrogen and hydrogen. So it is also called as air gas. Why are we calling as air gas? Because we are passing air with steam. So this steam and air together passing onto the coke that is burning, coke or coal. Coke or coal, we are sending air with steam. So ultimately we are producing some gas. So that is nothing but air gas. Air gas. So that is how it is called as a gas. So 2 moles of carbon and oxygen with nitrogen reacts together to form carbon monoxide and nitrogen. So these are the typical contents that are present and is usually the mixture of carbon monoxide, hydrogen along with some methane, an inert species of carbon dioxide, nitrogen, water, steam and small amounts of argon. So argon is also coming as an inert gas from this process. So it also contains methane, carbon dioxide, nitrogen, water from the steam that we obtain. So the steam as such, if it is coming out, it is in the form of water. So the reactions, what are really going on during this production, like producer gas. So we will see in detail. So this has a producer gas production system. So this has some zones. There are different reactions going on. So how the reactions are really happening? It has 4 zones. Ash zone. First, what is that ash zone? We are ashing something. So this is the lowest zone, consists mainly of ash. So this ash is, where is this ash coming from? We are taking coal or coke. Coal or coke. So the incoming gas and steam mixture is preheated in this zone. So here we are heating the ash in with the air and the steam mixture that is again preheated before it is reacting with this coke or coal. So this is the lowest zone that is happening. So air mixed with a little steam is sent through a inlet from here. So this is the inlet for air and steam. Next is the combustion zone. So this is a zone next to the ash zone. Here is a combustion taking place. So here the coke is oxidized to carbon monoxide and carbon dioxide. Why? Because the coke is nothing but containing carbon content. So we have seen in the previous solid fuels, like highest percentage of carbon is having in the coke or coal. So this carbon is converting to carbon monoxide and carbon dioxide because of oxidation, adding of oxygen. So addition of oxygen, oxidation is taking place, oxidized to carbon dioxide and carbon monoxide. So both the reactions are exothermic. So whenever this reaction is going on, it is exothermic. It is because it is nothing but giving heat or energy out. So hence the temperature of the bed reaches 1100 degrees centigrade. So whenever we are combusting this coke, there is a release of heat or energy. So release of heat. So what happens? Because of exothermic reaction, there is a release of heat. So we are the temperature will rise to 1100 degrees centigrade. 1100 degrees centigrade. So carbon, when it is oxidizing, it gives carbon monoxide, carbon dioxide. So this is the exothermic reaction giving rise to heat, and this is the amount of heat that is produced from each of the reaction. 29 kilocalories from carbon dioxide formation and 95 kilocalories from carbon monoxide formation. So this is how there is an exothermic reaction going on because of combustion or oxidation process during production of producer gas. So next is the reduction zone. So what happens in the reduction zone? So this is the middle zone present. Here both carbon dioxide and steam combine with the red hot coke. Why? because there is heated coke already present. So the carbon dioxide and the steam that is going in here will react with this red hot coke already present and liberates hydrogen and carbon monoxide. So that will liberate hydrogen and carbon monoxide. So this reaction will give rise to carbon. With the carbon is nothing but the coke that is present. Carbon dioxide is forming carbon monoxide, 2 moles of carbon monoxide. So it is taking up some heat. The heat is received here in the reaction or consumed in the reaction. Therefore, this reaction is endothermic. So how much heat is consumed? 36 kilocalories of heat is consumed. Whenever heat is consumed, it is given as minus. It is given as or denoted as minus 36 kilocalories of energy is consumed for this particular reaction. So these reduction reactions are endothermic and the temperature of this zone is 1000 degrees centigrade. So here the temperature is 1000 degrees centigrade. Then the carbon with the moisture or the steam that is coming in is also reacting and converting to carbon monoxide and hydrogen. So this endothermic reaction is consuming 29 kilocalories of energy. So this much of energy is consumed here. So that is why the reactions are endothermic. So if no steam is supplied, the temperature of the producer rise and this may fuse the ash and refractory lining. So what happens if really there is no steam that is in from the inlet? There is a rise in temperature because of the combustion reaction. The temperature will keep on rising, increases the temperature, and it will fuse the ash, already present ash of coal or coke, with the refractory lining that is present here. So that will fuse together and get deposited here. So there is no further reaction taking place. Next is a distillation or drying zone. So this is the top zone that is present. So in this zone, the temperature is 400 to 800 degrees centigrade. The downcoming coal is heated by outgoing gases. So the coke that is coming here, that is sending from here, will be is heated by these outgoing gases. What are the outgoing gases? Carbon monoxide and carbon dioxide. So these are the gases that are produced during the reaction. So these gases will be reacting with this coke and it will get heated up. So the heat given by the gases and heat coming out from the reduction zone will distill the fuel. So therefore the heat coming out from the reactions and heat that is given from the reactions is forming a producer gas and therefore giving out the fuel or the producer gas from this entire system. So what are the uses of this producer gas? It is a reducing agent in metallurgical operations. For example, if there is some reactions that are going on, so that during that it will be can be used as a reducing agent, and also used for heating muffle furnaces, then open hearth furnaces. These are big furnaces. So muffle furnaces generally operate at very high temperatures beyond 500, greater than 500 degrees centigrade. Whenever we want more than 500 degrees centigrade, we go for muffle furnaces and open hearth furnaces. So these producer gases will help in heating up these furnaces quickly. So next is the natural gas. In the natural gas, one of the example is the compressed natural gas. In abbreviation, we call it as CNG. CNG cars, CNG auto rickshaws are the famous automobiles that is running with the CNG gas. So it is nothing but the compressed natural gas. So the main constituent is the methane. It also has the main constant methane that is present. So it is a fuel gas, a substitute for gasoline, is nothing but the petrol, diesel or propane. So or propane in the form of LPG. So it can be a substitute for these types of liquid fuels. So it is more environmentally friendly or clean alternative to those fuels, and it's much safer than other fuels in event of spillage. So if spillage is nothing but whenever there is a spillage, it will catch fire immediately. So it is always better is using the CNG vehicles or automobiles for running the vehicles, because the petrol spillage will produce hazardous fire accidents. So it is made by compressing natural gas that is containing methane. So the natural gas containing methane is compressed to high pressures so that it will be used for any automobiles. To less than 1% of its volume, it occupies at standard atmospheric pressure. So the natural gas is compressed in such a way that it only occupies 1% of the volume of the whole container. So the 8 STP conditions are standard conditions during operations and most widely used in cars and locomotives. What are the properties of CNG? It is the cheapest, cleanest and least environmentally impacting alternative fuel. Impacting is nothing but pollution. So it is the least polluting fuel that is used in automobiles. And vehicles powered by CNG produces less carbon monoxide and hydrocarbon emissions. So nowadays, the all the pollution is just because of the pollution or the carbon dioxide monoxides that are released from the vehicles. So CNG is one of the best alternative that can produce very less amounts of these pollutants and also can happily be used for generations together. So it is less expensive than petrol and diesel. So this CNG is really less expensive comparatively with the petrol and diesel. The ignition temperature of CNG is about 550 degrees centigrade and requires more air for ignition. So the start requires more air for the ignition. So that is the only one we have to consider. And accordingly, the vehicle can be, or the storage can be varied. So what are the constituents or the composition of CNG? Methane is about 90%, ethane is like around 4% of ethane, then propane 1.7 and C4 carbons. So any carbon like butane, like it is around 0.7, so C6 carbon content is around 0.2. Carbon dioxide and nitrogen together is 0.2%, hydrogen 0.1, monoxide, carbon monoxide is 0.1 and oxygen is 0.5% and sulfur 10 ppm. So which is very low in content. So overall, if we see, the methane content is very good. So that is why it is really producing less greenhouse gases like carbon dioxide and monoxide. So if at all present, it can produce more, but it has very less carbon monoxide and carbon dioxide content. So that is why it is clean and safest fuel for the automobiles. So next is the petroleum gas, the third one. In the gaseous fuels, we have 3 gaseous fuels. We have 3 manufactured fuel gases, then natural gas, then petroleum gas. So now we will discuss the petroleum gas, and the last one. Petroleum gas is also called as liquid petroleum gas and liquefied petroleum gas. That is nothing but, in abbreviation, we call it as LPG, is one of the good example for this petroleum gas. So this petroleum gas is nothing but to be obtained during refinery of that fossil fuels or the crude oil distillation. So it is non-renewable source of energy. Why? Because it is obtained from the fossil fuels, that is the extraction of crude oil from the earth crust and then refining or distillation is producing this petroleum gas. Therefore, it is non-renewable. So, there is a chance for depleting. So, that is why it is called as non-renewable. So, extracted from crude oil and natural gas from the nature. So, the main composition of LPG are hydrocarbons containing 3 or 4 carbon atoms. Any hydrocarbons containing 3 to 4 carbon atoms are the composition. For example, like it contains a propane and butane. Propane and butane are the composition for the LPG gas. So it can be easily condensed, packed, stored, and utilized, which makes an ideal energy for wider applications, wide range of applications. So in India, we are using some like Indian HP and gas were some of the good examples of LPG gas that we are using for our daily applications. So this can be used like packed and stored easily and can be used for different applications. So generally it is non-toxic. So LPG is not toxic, but the handling of LPG gas is very important. Otherwise, it is dangerous. So LPG should be treated with respect and kept away from children whenever possible. So the leakage, if there is some leakage, it will give rise to some fire accident. It will catch fire easily. So that is why it has to be treated properly and should be regulated properly. The gas flow should be regulated properly. So the main reason for converting to LPG is its superb portability and convenience. What's this portability? Because whenever there is no gas supply, then in the remote places, for example, in remote places, whenever there is no ordinary gas availability, this gas can be sent and can be used in any remote area. So that is the meaning of portability, and because of that, it is the very good application for the domestic appliances or the applications. Only two big disadvantages are the safety and cost. Safety is even if we compromise with cost, safety is utmost care we have to take care when we are using LPG gas. The knowledge of using these gaseous fuels is very important than cost investment. So thank you. We will discuss the applications in the next session. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.